We can begin this problem by identifying the two pieces of our function we're going to use to apply the product rule. So the first piece is 3x, and that's being multiplied by e to the 2x. Now the product rule tells us that if we have a function that's made up of two pieces or two smaller functions that are being multiplied, we can find the derivative of that function by taking the derivative of the first piece, multiplying it by the second piece, and adding that to the first piece multiplied by the derivative of the second piece. So in this case, we're looking for f prime of x, the derivative of our function. And our first piece is going to be represented by 3x, and our second piece, or our b, will be e to the 2x. Now if we substitute this in, we'll end up with 3x prime, or the derivative of 3x, times e to the 2x, and then we're going to add to that 3x times the derivative of e to the 2x, or e to the 2x prime. If we take care of our derivatives, we'll end up with 3 multiplied by e to the 2x, and we add to that 3x multiplied by 2e to the 2x. This is going to give us 3 times e to the 2x plus 6x times e to the 2x, which we can simplify by factoring out a 3e to the 2x, which leaves us with 1 plus 2x. Now that we have our derivative tells us what our slope is if we plug in a point that we are interested in. So the slope of our function at the origin, at 0, is going to be our derivative with 0 plugged in for x. And so that is going to result in 3e to the 0 times 1 plus 0. This is going to be the same thing as 3 times 1, or 3, which means the slope of our tangent line is 3, and we can plug it into slope-intercept form, y equals 3x plus b. Now to solve b, we can plug in the point that we know is on our line. We know that y is 0 when x is 0. And so this gives us 0 equals 0 plus b, which must mean that b equals 0. So plugging this in, we end up with our final answer, which is that the equation for our line is y is equal to 3x.